So hello everybody. Everybody. I don't know what I'm even talking about. But uh, oh yeah. Okay. Okay. So looks like it's okay. What I'm saying here on the mic looks okay. Okay. Even though in real life it's I don't know what I'm even talking about. But anyways. So let me try go here. This one. Okay, this is not going to be that long. Okay, we just do some slight adjustment stuff here and there, and then after it should be good. Okay, this one should be good. Okay, should be, it is what it is. Okay, okay, okay. So looks like I have new stuff here, so maybe, yeah, so maybe I also can do this. Okay, so why not? Okay, okay. So let's finally go, shall we? And please mind you, I'm not 100% very healthy today. You can hear my voice. It's not. Yeah, sorry. It's not entirely good though, but I'll try my best. Okay. So, so please be note that some of my pronunciation, it can butcher up even more compared to my my typical healthy voice. So it is what it is. But with that on the way, let's go. So hello everybody and good hello everybody and good morning here. It's good morning from Sarawak, from Borneo. It's almost 5:27 a.m. here. Yeah, just 8 minutes. Sorry. Oh, what am I even talking about? Okay. Let me go. 5:27 a.m. Okay, Mark. Okay, already. So it's on Saturday, 16th of May, 16 May 2026. So yeah, fortunately, it did not entirely. How do I say? It did not entirely. Mm, how do I even want to say? Let me find a word. Fortunately, it did not interfere with my with going to church today, so it's fine. I still can go stream. Yeah, it's pretty early morning, so why not? So today, yeah. Sorry, that's why I said just bear in mind with me. Not really healthy, so so will I will stumble and butcher lots of words today in comparison to my healthy self. So please take note. Okay. So today we are going to watch the. So today in this very early morning, in at least my place right now, we are going to watch the launch of the SpaceX's Falcon 9 Block 5 rocket that will carry mm, SpaceX CRS-34, okay, cargo resupply spacecraft for heading to the International Space Station, to the ISS, okay, located around 400 kilometers circular in, on the low Earth orbit, okay, and 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 also need to mind you that even though this is a Falcon 9 Block 5 rocket, okay, in this mission it's not going to be using the payload fairing as usual, but instead it's the site where usually there's payload fairing and whatnot, it's being and also payload adapter, it's now replaced with the Cargo Dragon, the C209, Okay, that one already, if it's going to launch today, it's going to be its sixth flight. Okay, with with some of its service module here and there. That one will be docking to the International Space Station in the Harmony Nadir forward module. Okay, with the, how do I even say here? Okay, mm, with the booster, where is it? Booster B 10 1096. Is it? Uh, Let me see. Because I forgot to mention that part as well, so might as well I'll just show you here. Okay, yes, correct. With the B10 1096, it will be the flight numbers. It will be the sixth flight as well. The same with the C209. So sixth flight altogether. So with the B10 1096, it will be landing back to the landing zone 40, which is just located few hundreds of meters away from the launch pad. So, from the launch pad of the Slick 40, which is the Space Launch Complex 40, located in the Cape Canaveral Space Force Station. So we are also going to see that as well. And yeah, for the Cargo Dragon, when it's re-enter back, it will be recovered back by the Shannon ship as well. So keep that in mind. And also, to give you a little bit of information, Falcon 9 Block 5 rocket essentially is a all Kerolox propellant stages, both for the first stage and also second stage. Okay, with the liquid oxygen as the oxidizer and super refined kerosene as the, which is the rocket propellant one, as the fuel. Okay, and the Merlin 1D rocket and the rocket engines powering into this flight. Okay, the first stage powered by the 9 Merlin 1D rocket engines. That one, how do I say, that one is a gas generator cycle rocket. Okay, gas generator, essentially what it does is that it before it fully how do I say, a small portion of this propellant of small portion of this propellant, liquid oxygen and also super refined kerosene, it will be burned inside the pre-burner chamber, just to move the turbine to the operating speed. If I remember, it's around, it can be varied, but it can be around 40,000 80,000 plus RPMs depending on the specification, just to move the turbine of the liquid oxygen and also the super refined kerosene, so it can be burned into the first it will go into the cooling wall jacket, and then eventually into the combustion chamber, while this already pre-burn stages, it will be expelled out into the small exhaust, not entering into the into the combustion chamber, which is why it's called as that's why the gas generator cycle also called as the open cycle as well. So that's basically the operation in the nutshell. That one is the how the Merlin 1D rocket engines functioning, and also including its vacuum optimized version as well on the second stage. Okay, which is called as the Merlin vacuum engine, or vacuum Merlin, but usually we just call it Merlin vacuum engine. Okay, Merlin vacuum engine is basically like the widen up thrust optimized specific version of the Falcon of the Merlin 1D rocket engines. Okay, so that one is for the space environment operation to ensure that to ensure that when it run when the rocket engines ignited on space, it can actually capture a lot of thrust efficiency and also effectiveness. You because usually when you try to light it up into the space with the shorter nozzle version of this, let me try show you here. Okay, let me show you. Okay, so here how is the Merlin 1D rocket engines looks like. Okay, you can see it's pretty short in comparison to the okay. So even the Falcon Heavy, it has some kind of slight differences. Okay, that's also very interesting. You can see. Okay, but this is basically in the nutshell how Merlin 1D rocket engines looks like here. Okay, let me see. Yeah, maybe another one that I can show you. Yeah, so it should be something like this. Okay, and also let me see. Yeah, just give me a little bit of time. Okay, yeah, so what you see on the left side is the Merlin 1D rocket engine. That's how you know that one is a little bit that one is pretty typically shorter, not bell nozzle rocket engines, also known as the D-level rocket engine, D-level nozzle as well, because if I remember earlier on, D-level also discovered, not only discovered but also invented this kind of stuff. And then originally this kind of shape, yeah, this kind of rocket engine shape, originally it's used for the steam locomotive engine, but eventually rocketry decided to just adopt it as the main propulsion form of the modern aerospace stuff. So this is how it looks like. Okay, on the Merlin 1D rocket engines, on the left side is, let me see, it's something like this one. Okay, yeah, sorry. So this is the Merlin 1D rocket engines. Okay, kind of short there, but pretty typical otherwise. And this is where after it burns into the pre-burner chamber there, eventually it will be expelled out here. And while the rest of the most of the propellants that's already been turned around and also been moved by the turbine, the liquid oxygen and also the super refined kerosene, eventually it's moved down. First, sometimes depending on which one, it can be either liquid oxygen or super refined kerosene. It will be going into this cooling wall jacket here, and eventually some of it will be moved together inside the combustion chamber as well. Okay, where this move together, and then eventually it produces thrust by this kind of the nozzle throat here, which is basically artificially restricting it to produce thrust, pressure, and force, and what so on. And also the same can be said with this small exhaust there. And this is how the vacuum Merlin rocket engines looks like. Okay, you can see there are some, even the part is pretty almost identical, but there are some differences. You can see, for one, the rocket The rocket nozzles bell are much more bigger. The surface area are even way bigger. Not surface area. It's more like the area thrust ratio here are much more bigger in comparison to the Merlin 1D rocket engines. Okay, you can see it's much bigger until reaching this part. Usually you don't want to make it. Yeah. Um, okay. Sorry. The looks like it doesn't properly track my face. Usually you don't want to make this uh rock. How do I say this rocket nozzle to be too big, because otherwise the advantage of it able to capture the thrust loss as well, to maximize an efficient size, it's not going to be that big. So usually it reaches until some point, okay, due to the space environment where the Earth's atmosphere, by by the by the time it's going to the space, the usually even on the first stage flight, usually the Earth atmosphere, it's going to, how do I say, it's going to gradually losing gradually losing its influence as it's going to the space, and also as the Earth's atmosphere getting thinner and thinner and thinner as it goes upward. Okay, which will cause the rocket exhaust flame to eventually losing its shape stability as well, which the rocket exhaust flame, usually when it's going expanding, okay, it can expand into the infinite. Let's just say, assuming the rocket exhaust flame, it did not reaches its ending. But however, what happened is that in real world, of course, the rocket exhaust flame, it's going to reaches its limit, and that's basically the extent of where the rocket flames will go. So usually they have to expand the size. Sometimes it can expand until how many it can be. To visualize it, it will be something like this. Okay, this is by the everyday astronaut. So this is astronaut. Okay, so this is how it looks like. Okay, sea level Merlin 1D rocket engines, and then vacuum Merlin 1D. You can see the size, the differences. I think, let's just say, if we even take this space one, it's practically double the size of the sea level of the Merlin 1D rocket engines in comparison to the vacuum Merlin. Yeah, so that's basically it in the nutshell. Yeah, and also apologize, I'm not 100% healthy, but I'm trying my best. Okay, but just to give you a quick update as well, because I know the NASA stream will start anytime soon. So this is the launch weather report so far. Okay, so looks like there's only 10% of the constraint for today, so which will be 90% goal for launch. So hopefully everything is good. Yeah, the only concern is just cumulus cloud, but however, should it launch today, it should be good. And the temperature, okay, they are using imperial system, but however, I might be able to translate this. If you see the weather conditions, okay, the weather is good, visibility is also good, around almost around 9 plus kilometers of the visibility, or around 7 plus miles. The temperature apparently is, let me see, is 27.22 or 23 degrees Celsius, or around 81 degrees of Fahrenheit, with the humidity of 67%, and liftoff winds, which is, let me see, how do I even translate this? 200. Okay, I'm not 100% sure, but just to give you some idea, okay, it will be it, it will be the liftoff winds will be going around the bearing of 100 degrees around, let me see, 12, okay, 12 miles to 17 miles, which will be in the range between 19.31 31 or 32 kilometers to 27.3 36 kilometers of the liftoff winds. Okay, so that's basically it in the nutshell. Okay, the clouds, the cumulus, you can see it's going to be scattered, okay, with the base around 3,000 feet, or should be around almost 1,000 meters. Okay, or around 914.4 meters. Okay, with the tops we going for 10,000 feet, which will be around 3,048 meters of altitude. So it's not going to be that long. So however, that's going to be slight problem, but it should be okay. Okay, and this is the news and whatnot. Okay, this is how it looks like, and let's go with the nutshell how the mission will go. So okay, so today it's going to be carried around about 6,500 pounds, which will be, if I even translate this, which will be around 2,948.35 kilograms of supplies, and also whatever space experiments, payloads here and there, food, water, oxygen gas. I don't think oxygen gases is here, but it should be okay. Okay, so this is the science highlights. What's going to be the mission? It will be the ODYSSEY. How, just to evaluate how well Earth-based microgravity simulators recreate space conditions using bacteria. Okay, and then later on will be the story, part of the STP-11, which is the space test program dash Houston 11. That one also hosted not only by the NASA but also by the US DoD, the Department of Defense. Okay, the story, it will monitor charged particles in orbit around the Earth, okay, which respond to space weather, space weather, and also to that can affect the any kinds of assets. It could be power grids, satellites, and also this one will help researchers to understand and predict and respond to these changes, how it happens as well. And it will be the Laplace, okay, which will study the movement and collision of dust particles in microgravity, to understand particle motion in space, okay, which they hope to understand how the planet forms, okay, in our solar system, and especially our Earth's origin as well. And the next will be the green bond, which will observe how bone cells grow in space on a bone scaffold made of wood to help osteoporosis patients. Okay, this one it's actually made from the rattan wood, if I remember correctly. Yeah, rattan wood, which is also surprisingly quite very common to be find here as well. In Borneo, it's pretty common as well. So pretty interesting how this will be done as well. Yeah, I would like to see it. And this one will be the Spark mission, which will evaluate how red blood cells and spleen change in space for future astronauts, and to protect them as well. Okay, so it will be observe the human samples and imagery. It will be taken before, during, and after the space flight. Okay, so for this mission, the for the how do I say the S- SpaceX CRS-34 that will be monitor the arrival of it later on will be NASA astronaut Jack Halfway, okay, and also the ESA astronaut, the Sophie Adeno, okay. So yeah, that's basically in a nutshell. And this is how the cargo breakdown looks like. Oh yeah, sorry. Yeah, so to break down out of this total cargo, so apparently the total pressurized with packaging is 2,132 kilograms, okay, or around 4,701 pounds, which actually the breakdown would be the crew supplies 618 kilograms, which is 1,000 or around 1,363 pounds. Science investigations, which is 831 kilograms or around 1,834 pounds. Spacewalk equipment 128 kilograms or around 282 pounds. Vehicle hardware, which is 469 kilograms or around 1034 pounds. And computer resources, which will be 84 kilograms or around 186 pounds. And the rest of it, the unpressurized payloads, which will be around 816 kilograms or around 1,799 pounds. Okay, so for the launch as well, they will be carrying the European Enhanced Exploration Exercise Device power cable. This one is for the replacement power cable, apparently, um, for it. Okay, sorry, just sneeze a bit. And also it will be carrying the catalytic reactor, very vital component for the water recovery and management system, so which oxidizes volatile organics, okay, from wastewater, that will be removed by the gas separator and ion exchange bed. Okay, for this one for the orbital replacement units. Okay, so this one is to launch as part of the orbital sparing in case anything happens. And then universal retreat concentrate tank. Okay, this one is passive tank. Provide alternate retreat concentrate to the universal waste management system, UWMS, and then eventually with the waste management compartment, WHC. So okay, so two units are launching to maintain this hardware in tandem with Russian pre-treat tanks that are currently on use. Okay, so this is basically will accompany it. It will be using the tank universal pre-treat concentrator tank adapter to connect with the Russian host. Okay, so another additional equipment, ultra prop to replace a worn ultrasonic inspection tool, remote sensor unit with to store space for the station's vibration monitoring system, and flexible repair patches for sealing the pressure hull, okay, if it needed as well. Also will be deliver an updated armadillo, which is stands for AUGA remediation, advanced deionization and limited life optimization, cartridge and host assemblies. This one to improve water processing for gas generation. Sorry, for oxygen gas generation. Okay. Along with a nitrogen recharge tank assembly to help maintain the station's gas reserves. Okay. And the rest of the story, the return, when it returns back in mid June, it will bring back an ocular imaging device used to monitor crew health, crew eye health. Okay, a sorbent bed that filters trace contaminants from cabin air, and a separator pump from the waste and hygiene compartment, and then the advanced plant habitat, which supported long duration plant biology studies that also will return. Okay, this one for the museum display, and a pressure measure management device that recovers vestibule air during depressurization also will be coming back. This one to repair and also storage as ground spare as well. Okay. So, but that's it. I think I uh, talk too much. I might as well just show you here. Okay. Okay, so this is it. Okay, stage one. Okay.
Underway for both the first
Okay,
and second
so
stages.
this is
For
it.
the first stage, they're about 83%
We are
of the way
going
there,
straight to the
and for the
live.
second stage, about 40% or so.
Okay,
Now, as we get closer to
so
liftoff, let's check back in
getting
with our
ready in.
colleagues in Hawthorne
And
and
looks
Ronnie.
like the weather looks
Everything is still
okay so
looking
far.
great here on the mission control side of things for
Yeah.
SpaceX. Right now, we are standing by just about 10 and a half minutes until our liftoff for a couple of key callouts from mission control and visual indicators that we are getting ever closer to liftoff.
Yeah, and also usually I
At about
would like
T-minus 7 minutes, you'll hear
to
a
talk a
pop from
lot, but
engine chill. That's when
but
we'll
due to
open
the
the engine
yeah,
pre-valves and start passing just a trickle of liquid oxygen through the Merlin engine pumps, chilling those engines down through the start sequence. We do that because the super chilled and densified liquid oxygen is really, really cold. And we use that process to bring all of the engine hardware down to a cooler temperature before flowing all of the LOX and RP1 into it during flight. Engine
yeah.
chill
So I just want
specifically
to
helps to prevent thermal
um
shock and ensures nominal engine performance on liftoff and all the
yeah.
way through ascent.
So basically this is what they are describing right now, just similar
We're
to
going to
what I
keep
want to say
listening
as well.
in for all of these updates from Mission Control, but in the meantime, let's check back in with NASA again. Joseph?
Okay, and also you need to remember that
Thank you, Ronnie.
typically I
Greatly
would
appreciate
like
it. And
to
yes, certainly looking
talk
forward
a
to it. We're
lot,
now
but
approaching 9.5 minutes until liftoff
my
of
current
NASA's
health right
SpaceX
now is it's
34th
not
commercial
100% good
resupply
at
services
this
mission
point.
heading towards the International
So
Space Station, which is a perfect
uh so
opportunity to introduce
so
you to the
I'm going
Expedition
to
74 crew.
talk
And we
only
mentioned
when
earlier
it's
that includes
necessary.
NASA
If it's
astronauts
not
Chris Williams,
necessary,
Jessica
I'll
Meir,
just
and Jack Hathaway.
I'm
They're
going
also joined
to
alongside by
be
Roscosmos
silent.
cosmonauts
Yeah,
Sergei
just to
Kutsverchkov, who
keep
is the
myself
station
good.
commander,
I
Sergei
I would like
Mikheyev,
to
and Andrei
use this
Fedyaev.
energy
Also joining
later
them
on
on
for
board the
the
International
commentary
Space
part,
Station is ESA
launch commentary
astronaut,
part
our
later on.
European Space
So yeah,
Agency astronaut,
I hope you
Sophie
can
Adno.
understand.
Now on tap for docking as the Dragon spacecraft makes its way closer and closer to station, it will be Hathaway of NASA and Adno of ESA that will be monitoring the Dragon spacecraft as it gets closer and closer to the orbiting
Okay, so
laboratory. Now for
this is
Chris
the
Williams, Sergei Kutsverchkov, and
expedition
Sergei Mikheyev, they
74
would arrive
crew.
on station
As
last
you can
November
see,
on Thanksgiving,
7
November
crew
27th,
onboarding
and are
the
now entering or
International
moving
Space
through their
Station.
169th day in space. And for Jessica Meir, Jack Hathaway, Sophie Adno, and Andrei Fedyaev, they would launch back on February 13th aboard Dragon Freedom as a part of Crew 12 and are moving through their 91st day in space. Well, as we get closer and closer to engine tilt, taking a look at the updated fueling, it looks like stage 1 RP1 load is about to wrap up, about 90% of the way there for the liquid oxygen of the first stage, and about 60% for the stage 2 liquid oxygen. But for now, as we get closer and closer to, as Ronnie mentioned, engine chill, and we continue
T-minus
to
8
progress in the
minutes.
countdown, now reaching 8 minutes to go until liftoff. Back to Ronnie Foreman in Hawthorne.
So as I mentioned earlier, now we are standing by for some of those key callouts and visual indicators that we are getting closer to our T0 time. The next major visual milestone we're going to get is actually about the transporter erector, which is the tall truss structure standing to the side of Falcon 9. You've got a view of it there on the right-hand side of
Okay,
your
you
screen,
can see
and again,
there.
we have
This is the view
LZ40 over there on the
on the
left.
top of the Falcon 9 rocket here. This one, as you can see, is the view of the Cargo Dragon C2019. Sorry, C2009. Ha. Okay, okay, okay. So this one is correct. What I'm saying. Previously, not really. But it's okay. You can see usually there's going to be pellet fairing and also pellet adapter, but not today.
Engine chill has started.
At about T-4
Okay,
minutes and 17
T-minus 7 minutes.
But bear with
Already
me, just get
engine
that
chill
announcement from
chill
Mission
has
Control
already
that
start
engine
on the
chill
first
has
stage.
begun.
Already start
Fun fact,
cooling down the
the
first stage
super chilled liquid
on
oxygen
the
on board
first
Falcon
stage.
9 is at about
On the
300
Merlin
degrees
1D rocket
below
engines,
zero.
all 9 Merlin 1D on the first stage. Yeah. And also forgot to mention that the super refined kerosene that they are using, this one they are using a super
RP1 load is complete.
okay, stage 1, the RP1, the super refined kerosene has already fully topped out. Okay, already full. Okay. And also, just to give you a little bit of facts, the rocket engines, sorry, the fuel itself that's being used in this flight, they are using the sub-chill version, which is slightly colder than usual, around negative 27.33 degrees Celsius, around around 81 degrees of Fahrenheit, something like that, to cool down the that 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 actually gives propellant density advantage of 20%, like that. Yeah, 20% of more propellant that can be loaded around. So that's pretty interesting as well. Okay, and now you're currently looking at the Cape Canaveral Space Force Station. This one is the specific launch pad of the Space Launch Complex 40 Slick 40, located in Florida, United States. T-minus 5 minutes. And get ready, you will.
Tanks are pressing for the start of strongback retract.
Okay.
Confirmation that Falcon 9 is getting ready for strongback retraction.
Okay, Falcon 9 ready for the strongback retract. You will see later on as the towers, as the launch. How do I say? The transport erector. It's basically going to retract slowly until the launch. Okay, entering at the terminal count, and now in the.
And we are heading into the final 5 minutes
okay,
before liftoff.
Into the internal power. Okay, okay. So basically, the power is now on board the Falcon 9, but however, it's not fully yet going to the internal power yet. It's still depending on the ground infrastructure. Still has external power. That one will only commence at T-minus 1 minutes later on, when the Falcon 9 onboard rocket computers already start for the final pre-check as well. We will see. And what a magnificent view of the seaside area as well, of the launch pad. So yeah, you can see there.
The range is also green to support today's launch. Now, if for some reason we do not launch today, we do have a backup opportunity. That'll be tomorrow, Saturday, May 16th at 5:43 p.m. Eastern Time. But right now, all systems tracking well as we continue to monitor the final progress of fueling and getting ready for liftoff.
You can see the strong back retract has already commenced. Okay, it's been done one by one, pretty slowly there. So yeah, T-minus 3 minutes mark. Okay. Okay, stage 1 lock slot has already complete, which is the liquid oxygen fully top up right now. So that's very good as well.
With the cryogenic plumbing on board Falcon 9. During flight, that helium pressurization helps force propellant into the engines as the tanks empty. In these last few minutes, Falcon
Depressurization as well. Also pressurized by using the helium. Yeah, the helium pressurizing the propellant,
We may hear
both
some more
propellant
call-outs
of
if the
the
engines are
liquid
sufficiently chilled
oxygen
as
and
we get a
also
little
superrefined
closer to
kerosene
liftoff. And again, we are
for
standing
good
by for
reason,
another
because it's
fuel loading and
neutral,
completion
okay,
call in
and it's
about 20 seconds.
practically propellant compatible to just pressurize the
And around this time, the second
the
stage
propellant
thrust
tank as well.
vector control
So that's why it's
actuators are
being
being
used for
tested
it.
and checked out.
Usually it's
And
not
this is when
really that big,
SpaceX
very
moves the
small
nozzle ever so slightly to
bottle
make sure
tank,
that
in case
guidance
you want to
hardware is
know.
acceptable
So
for
that's that.
flight. And
So
about
T
2 minutes at the
minus
time of launch,
2
the
minutes
International Space
mark.
Station will be
Stage
flying
2,
some
launch load
260
is complete.
miles off the southern coast of Australia as we hear that stage 2 LOX load is complete and Falcon 9 is now fully fueled. The first and second stages are now fully loaded
Dragon
with
is
over
an
1 million
auto-idle.
pounds of rocket-grade kerosene is now Dragon
Okay,
moving into
good,
auto-idle.
good.
Coming up on a minute and a half.
Okay.
Left in the countdown. Now auto-idle puts the rocket
Okay,
in a
gas
state
vent has already started
that
as
computers
well.
can
You can see
understand before it takes
the
off.
liquid oxygen has already vented out the excess of it in preparation for the flight and getting ready
Now
in.
we are standing by for the T-minus 60-second call-out that Falcon 9 has entered startup mode.
Yeah,
At that
start out
point, the
mode,
rocket's onboard
mode,
flight
and also at
computers
the
will
same
have
time
taken
the
over. From there on out, the
propellant
countdown will be
pressurization
fully
already
autonomous.
going into the final countdown as well. Okay, T minus 1 minute, 60
Falcon 9
seconds.
has entered startup.
Okay, already
Yes,
entered
Dragon is in
startup.
countdown.
Okay,
Confirmation of startup
so
mode for
getting
Falcon
ready
9
in
and
at T minus
countdown for Dragon.
45
Our
or
last
44 seconds
milestone here is that our launch director calls go
into the
for
terminal
liftoff.
countdown should be the launch director given.
LD, go for launch.
Okay, launch
There
director
we
has
have
already
it.
given go
Just
for
inside of
launch.
T-minus 2 seconds,
So
the
good.
9 Merlin 1D engines on the
Looks
Falcon
like
9
the
first
flight is
stage will
going,
ignite. Once
and
they're
we
at full
shall see.
power, Falcon 9 will lift off
Getting
the
ready
pad
in
and
at
begin
T
its
minus
climb to
30
orbit.
seconds.
Let's
T-minus 30 seconds.
listen in for these final 30 seconds.
Let's listen in. T minus 20 seconds. Getting ready. Final countdown.
T-minus 15 seconds.
T minus
T-minus
10,
10,
9,
9,
8,
8,
7,
7,
6,
6,
5,
5,
4, 3, 2, 1.
1.
Ignition of 9 Merlin 1D rocket engines and liftoff. We have liftoff of the Falcon 9 Block 5 rocket carrying the Cargo Dragon C209 on the way to the International Space Station. Launching from the Cape Canaveral Space Force Station, okay, from the Space Launch Complex 40, Slick 40, you can see there, looks like the yaw, pitch, and roll program has already started from the view.
Everything is
What a
looking
very
good on board
magnificent
Falcon
view
9
there.
with our Dragon spacecraft.
You
We've
can
heard
see
those
there,
call-outs for mission
yeah,
control.
it's
The
already
rocket is
done
reaching
its
downrange,
move
and
as
the full
well.
9
Power
Merlin
and telemetry nominal.
engines
You can see
continue
due
to
to the
perform well.
complex hydrocarbon
We're just about to
rocket,
throttle down
you
the
can
engines
see
to
on
prepare
the
for max Q, the point of maximum
for the most
aerodynamic pressure during ascent.
bigger
Max
flame
Q
body
happens
side
when the
there
combination
is
of
the
speed,
orange red, and then okay,
and air pressure
supersonic
put the greatest
Mach
stress
1
on the vehicle.
getting
And
ready
with
in
our
for
call-out from
the
mission control,
max
we know
Q,
that Falcon 9 is
the
moving
maximum
faster
aerodynamic
than the speed of
pressure
sound.
fully exerted on the rocket itself. Okay, as you can
Max
see,
Q.
okay,
Here's that
max
call-out for
Q,
max Q.
so
Now
already
coming
reaches
up, there are
max
going to be several
Q.
major events that happen back to
And you
back
can see
really
due to
quickly.
the
Main engine cutoff, stage
complex hydrocarbon
separation,
being
first
burned
stage
there
flip,
of
second
the
engine
rocket
start,
propellant
and
1,
post-back burn
you can
start.
see the
Main engine cutoff will
orange red
likely be
color
called out
there.
as MECO. That's when
And
all 9
before we
engines on the first
see
stage shut down.
it's
That'll be followed by
looking like
stage
that, if you see
separation.
on the
There's that call-out
tail
for
end
NVAC
side
chill
is
on board the
the
second stage. Of
is the
course, before we
bluish
can start
color
the
there,
second stage, we do have to
resulting from the
separate those two stages. The
resulting
first
the
and second stage
from
will
the
be
resultant
separated and pushed
hydrogen
apart from one another
molecule.
when we hear the call-out
This
for
one is
stage
mostly
set.
by
Then the
the
first stage will
combination
flip
of the
around using
carbon and
small
also
thrusters so it
hydrogen
can head back to Earth.
molecule as well being burned out with the complex
A few seconds
long
later,
chain there.
we'll light that second stage MVAC engine and
Okay,
continue pushing Dragon
and
to orbit.
as we are getting ready for the stage
After all of that
separation
is
on the
done,
first
the first
stage,
stage will perform its boost back burn
I
to
mean,
steer
as
itself
we are
back
getting ready
toward the
for the
landing
MECO,
site.
my engine cutoff of the Merlin 1D, 9 Merlin 1D rocket engines, get ready in. Main engine cutoff, MECO.
Main
Okay,
engine cutoff.
MECO, main engine cutoff, stage separation, and we have stage separation.
Separation confirmed.
And we start on the second stage, Merlin vacuum engines, and already start on the Merlin vacuum engine, and the boost back return has already started on the first stage,
Great views
guiding
on
it
your
back
screen there, as you
to
heard,
the
and
landing
hopefully
zone
saw
40,
all of those key
just
events
located a
taking
few
place. Main
hundred
engine
of
cutoff,
meters
stage
away from the
separation, stage one flip, which
launch
is
pad,
happening
the
on the
same launch pad
left-hand side of your screen.
where the
Second engine
Falcon
start
9
on the
rockets were
right-hand side of
launched
your screen, and the beginning of
just
our
now.
boost back burn. Now, coming up
And
shortly, we should hear the
coming
call
up,
out for
3
completion of the
minutes,
boost back burn
T
on the
plus
first stage.
3 minutes mark. Okay.
This burn helps to steer the booster back toward the landing site,
And
is
you
the
can see
first of 3 burns the first stage
both of
performs
these
on
boosters
its return to
officially
LZ-40 at Cape
already
Canaveral Space
crossing
Force
the
Station.
internationally defined
We are expecting
space
that call out
boundaries,
in just
which
about
is the
5
common
seconds.
line, and already passed the US defined space boundary as well, which is located 80 kilometers or around 60 miles. In imperial terms for the
Stage 1 boost
space
back shutdown.
for the internationally defined space boundaries, it will be 80
And
miles.
once again, thank you for joining us as you
And
continue
there
to
you
follow
can
along with
see
NASA's SpaceX
the
34th commercial resupply services
and there you
mission. Now
see
3
the
minutes and a little more than a half into today's flight. Takes about
boost back
9.5
burn
minutes to get into
already
orbit and
ended.
all set. As Dragon on the right-hand side with that Merlin MVAC engine
Okay,
on the
and
right.
the grid fin has already started deploying
Continue its
on the
chase to the orbiting
first
laboratory,
stage.
and there you can
That
see that
fin
stage 1
originally
making its
it
return back
uses
to Earth
the
on the left-hand
aluminum
side.
alloy on the
We
few
have on-time
earlier
liftoff at 6:05 p.m.
reusable
Eastern Time from Space Launch
reusability
Complex
flight
40
of
at
the
Cape
Falcon
Canaveral
9, but
Space Force
eventually
Station.
it's replaced
Now,
by
in order
the
to make it
titanium
both
alloy
sides, stage one
due
will
to
make
the
its return
aluminum
back to
alloy
Earth.
being
A
more
couple things have to happen. 2 more burns to
erosive on
execute
the
the entry burn, where 3
yeah,
of the Merlin engines
being
will
much more
reignite,
erosive
and this helps slow the stage down as it
on the
re-enters the
hypersonic
upper part
flight,
of Earth's
especially when it
atmosphere.
enters back
And
in
following the
comparison to
entry
the
burn, the
titanium
booster will
alloy.
go through its landing burn.
So this is
And
what
this is a single
SpaceX
engine
used
burn that
till
brings the
this day.
vehicle speed down rapidly in order to land back on Earth. And we should be hearing those call outs for that entry burn in just a couple of moments from now.
Okay, right now the
That's right, Joseph. We
velocity
are
on the
standing by for
second
our
stage is
entry burn, which we're expecting to
more
begin
than
in about 2 plus
9,400
6 minutes
kilometers
and
per
10
hour.
seconds.
Altitude is
Now, during that entry burn,
167
Falcon 9
kilometers.
is decelerating by firing its Merlin engines.
Okay,
Though
while
the
on the first
vehicle is
stage,
still moving really
almost
fast.
almost
This
going
causes it to fly through
back
Merlin's
from
exhaust
space
gases,
from
which
the
are also
internationally
known as the
defined
rocket
space
plume.
boundary.
That deposits
Okay,
a layer
back
of
from
soot
the
on the vehicle's
international defined
surface, which is
space
why our
boundaries.
flight-proven rockets
100
look the way that they
kilometers,
do.
80 miles
The
already
soot
back
comes from the
again.
carbon-based
US
fuel that
defined
Falcon 9
space
uses,
boundaries,
and
though
with each
still
flight, that
there,
soot builds up a
technically.
little more on the outside of the vehicle. We also heard that call out from Mission
Okay,
Control just a few
get
moments
ready
ago
in,
that both vehicles
as
are
the
on
entry
nominal
burn will also start
trajectories.
on the first
You can
stage,
follow the
but not
trajectories
before it
along at home in the
crosses
bottom
the
corners of your screen.
space
We have stage 1 on the left
crossing
and
back
stage
from
2 on the
space.
right.
Okay, already crossing back to the US defined space boundary, below
Now
60
5.5
miles,
minutes into
below 80
flight,
kilometers,
a few more
and
moments
the
to go as we
velocity on the
continue to
first
follow
stage,
along the path of NASA's SpaceX CRS-34
4,000
commercial resupply
kilometers per hour,
services mission. And there you
altitude
can
is
see a great view of
66
stage 1 on the
kilometers
left-hand side.
and counting down.
The grid
Get
fins
ready
that
for
Ronnie
the
brought up
entry
earlier
burn
in the
start
broadcast
to
just ahead
slow
of
down
launch. Falcon 9 is equipped with four
the
hypersonic grid
first
fins, which are
stage
positioned at the top of the first stage and
booster.
are used
Okay, stage 1.
and used for
Entry
steering
burn
as
has
it
already
returns
started.
to
Here we
Earth, as you
go.
heard the start of
Only one Merlin 1D. Okay,
the
just
entry
already
burn
ignite.
for the first
That one,
stage.
for the most part, you can see when
And
entry
those
burn
grid
start,
fins
not
are a
only it
critical
slows
part of
down,
Falcon 9's reusability
but the
system.
rocket flames
So entry burn
serve
just completed. As you head
usually
down,
serve
now we'll
as a
look for that
protective
landing burn as it
layer
continues
as
to
well
make its return back to Earth,
to ensure
and it
that
will
it's
begin
not
its
suffering the
descent
full
into
brunt of the
landing zone 40
atmospheric
today.
heating.
And on the right-hand side, continuing to
So
track the
that's
path
how
of
it's
the
done.
second stage, in which the Dragon cargo spacecraft up
Okay,
top of
so
that second
let's
stage
focus
making
on the
its
first
way
stage
into
booster.
orbit. Now 6.5 minutes into today's flight. Now again, moments away from entry
Here we
burn, we
go.
should see
Should be ready for the
stage 1
transonic.
light back up as it
Okay,
will
it's
rapidly
still going into the
decelerate in
supersonic.
preparation for landing at landing
Okay,
zone 40.
stage 1, transonic. Okay, and also the flight commission system no longer
And
needed on the
milestones
first stage.
continuing
So
to check off for the
it's already
stage
been
1 as it
safe.
makes its return
And get
back to
ready for the
Earth.
landing burn, which should start
We'll
now.
keep an ear out for that entry burn start.
Okay,
Entry burn shut
entry
down.
burn has already
Should get
started.
some
You
great
can see
visuals
there.
off the
Oh,
so
awesome
landing
sonic
burn now
boom there.
underway, and that's the single engine that slows down stage 1
Okay,
rapidly
and
ahead
getting
of
ready
touching
in.
down
Landing
back
leg
on
should be
landing
deployed.
coastline.
Getting ready for the landing of the to the landing zone 40. Here we go. Landing, 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 landing. And nice. Stage 1 landing. First stage booster has already landed back. Welcome back, B1096. Welcome back. And now we can focus back to the second stage as it goes to the orbital velocity. As it, yeah. So as we are getting ready for the orbital velocity, which should target around 27,700 plus kilometers per hour. Could be a little bit more. We shall see that soon. Get ready.
That'll conclude the roughly 6-minute burn by this engine needed to get Dragon into the proper orbit to align with the International Space Station.
Yeah, which is the 400 kilometers, just in case you want to know. Okay. Stage 2, FTS is safe. Okay. Flight termination system on the second stage is no longer needed. So the missions can be completed right on time. Get ready. You can see the velocity is almost 27,000 kilometers per hour. Okay, it's already shut down. Okay, lower than expected, but lower from my expectation, but it's okay. So the velocity, final velocity is 27,011 kilometers per hour. Altitude is 198 kilometers, and the mission elapsed time almost 9 minutes. Okay, nominal orbit insertion confirmed. Looks like
spacecraft separation.
Okay, get ready for the separation of the Cargo Dragon spacecraft. Get ready in. Less than few seconds from now.
Towards the International Space Station, again carrying 6,500 pounds of critical cargo, science, and supplies to the orbiting laboratory.
Here we go. Separation of the Cargo Dragon spacecraft here, the C209, already gone for the sixth flight at this point. The same with the first stage booster B1096, already done its sixth flight as well. So, congratulations to congratulations to NASA and SpaceX for this successful completion of this mission. I mean, this is just a beginning, but yeah, for the launch part, congratulations already completed so far.
Which was followed by the successful landing of Falcon 9's first stage at Landing Zone 40 at Cape Canaveral Space Force Station. At about T plus 8 minutes and 30 seconds, we had a successful second engine cutoff, or SECO-1, which was followed by confirmation of good orbital.
And you can see on the rocket on board, on the upper stage, the second stage, is the beautiful backdrop view of our planet Earth. So that's that. Oh, you can see there. Another interesting view.
Thank you very much, Ronnie. Great to work with you and the team again as we see another successful launch and the cargo resupply services mission, the 34th for NASA and SpaceX, heading towards the orbiting lab. And as you mentioned, we're monitoring the nose cone deploy on the tip.
Okay, get ready for the nose cone deployment to confirm later on.
We'll wait for the second set and then followed by the nose cone deploy. So once the nose cone is deployed, it'll expose the 4 forward bulkhead Draco thrusters that will execute a series of maneuvers necessary to raise Dragon's orbit and meet up with the International Space Station. And this will be immediately after Dragon separates from Falcon 9, which we just saw, and it begins with what we call now the activation and rendezvous phase of the mission. During this phase, Dragon is configured
for you can see there. Look at that view. From the separator there, you can see the front view of it. Oh, another one. Oh, what's that?
To the orbiting laboratory. Now, our initial orbit today for the spacecraft is 190 kilometers by 210 kilometers. And with those numbers, that represents the perigee and apogee of the orbit, or the lowest and highest point over the Earth, as we are now 11 minutes and 45 seconds into today's mission.
Oh, so looks like the orbit right now, 190 by 210 kilometers. Okay.
Ellipse. And now over the next several hours, in fact, looking at the phasing for Dragon to catch up to the International
So let's hear
about 37 hours
how the phases will go.
And 54 minutes, give or take, to track down the orbiting lab, with again a docking is scheduled for early Sunday morning. and that will be around 7 a.m. Eastern Time,
Yeah,
6
38
a.m.
hours.
Central
I'm
Time. Now,
correct
I
there.
alluded to there are 5 major burns that
Nice.
the
Nice research.
Dragon spacecraft or the firing of the Draco thrusters will perform to catch up to the International Space Station. And those burns are the phase burn, boost burn, close burn, transfer, and co-elliptic burn, which we mentioned earlier, that final. And that's all for Dragon to not only climb up to, but catch up to the International Space Station. And there you can see the pathway of where stage 1 and stage 2 took to get Dragon into its initial orbit today. Now approaching 13 minutes into today's mission. Now, if we can, let's transfer over to the
Okay,
mission
getting
control
ready in.
rooms
Mission elapsed time. T
as they
plus
are behind
13 minutes.
today's launch festivities. And you will see the teams both in Hawthorne and in Johnson Space Center. And the team's here with me in Houston, monitoring the orbiting laboratory, but keeping a close eye on today's flight. And of course, again, the team in Hawthorne in SpaceX operating today's launch. And there you can see on the right-hand side of your screen there, a look inside the International Space Station Flight Control Room
Okay,
as
the
we
left
continue to
side is
monitor the
the
progress of
Houghton
the Dragon
Houghton mission
spacecraft.
control
Now, again, we're continuing
by
to monitor the
SpaceX,
nose
and
cone
the right
deploy. The
side is
first set of
the
hooks have
Houston
opened.
mission
Now
control. Okay, by
keeping an
NASA.
eye on the second set, and we'll see the nose cone start to hopefully go in motion here shortly. And now you can see the SpaceX teams on the left-hand side approaching 14 minutes into today's mission. And then once nose cone is confirmed, we'll be joined on console here by Bill Spetch, International Space Station Operations and Integrations Manager, to go over today's missions, its importance to the orbiting laboratory, and what certainly has been a busy time for the International Space Station. Now again, docking of the Dragon spacecraft is scheduled for 7 a.m. Eastern Time on Sunday, May 17th, 6 a.m. Central Time. And we'll have all the coverage right here on NASA Plus and all the NASA channels beginning at 5:30 a.m. Eastern, 4:30 a.m. Central. We'll continue to monitor Dragon again, awaiting nose cone movement as the hooks have all opened up. Again, that nose cone located at the tip of the Dragon spacecraft, and now the nose cone is in movement, and we will see its first movements here
All
shortly.
right, so looks like NOSCON deployment there. We will see. Oh, here we go, here we go. This is the
Yes, we
visual
thank you for
view.
following along.
Okay, T plus 15 minutes.
And now
Minutes,
on
yeah.
screen, you can start to see daylight creeping in as that is inside of the Dragon spacecraft looking at the nose cone, and it is opening up to expose that docking adapter, which will come into play again on Sunday morning with NASA astronauts Jack Hathaway and ESA astronaut
Here we
Sophie
go.
Adno
Here
on
we go.
tap
You
to
can see
monitor their
there.
docking to the International Space Station in
Yeah,
those
the
early morning
NOSCON has already
hours.
deployed.
And a great
And
visualization
we
again of the
shall
nose cone
see
opening,
more and
approaching about the
more.
halfway point in terms of being fully opened and exposed to the vacuum of
Oh,
space.
okay. We still wait again.
Currently in their
Again,
off-duty period
yeah.
right now, and resting is the Expedition 74 crew, but they will snap into action once the Dragon spacecraft arrives to unpack the 6,500 pounds of cargo and supplies. NASA astronauts Jess Kamir,
Okay.
Jack Hathaway, and Chris Williams. We mentioned ESA astronaut Sophie Adno
T plus
and Roscosmos
16
cosmonauts
minutes into
Sergei
the flight.
Sverchkov, the current station commander, Sergei Mikhev, and Andrei Fedyaev. Temporary loss of visuals there on the nose cone, but it does continue to open up as we'll monitor as we just pass the halfway point. Teams on the left-hand side in Hawthorne, California, and SpaceX, and the team on the right here with me in the International Space Station Flight Control Room in Houston, Texas, continuing to follow along. We also mentioned there will be 5 key burns for the Dragon spacecraft to make as it begins its chase to the International Space Station. The first one will be the phase burn, which happens not too long after liftoff, in fact. That'll be a little bit later on this evening. And then the other 4 key burns with necessary adjustments will occur throughout Saturday and into Sunday. Nose cone now about 70% open.
Okay, the NOSCON
As the teams
already
here continue to come along.
70% open. Okay, we shall see any more status shortly. Let's listen in.
Just over 17 minutes into today's mission after an on-time liftoff at 6:05 p.m. Eastern Time from Space Launch Complex 40 is NASA's SpaceX 34th Commercial Resupply Services mission to the International Space Station, loaded up with 6,500 pounds of food, supplies, cargo, and hardware to the orbiting laboratory. And what has been a busy stretch of time, and it's always a busy stretch of time for the International Space Station, and we'll touch upon that with Bill Spetch here in just a moment, Operations and Integrations Manager. As the
Here
nose
we
cone now
go,
nearly
here we
in
go,
orbit,
here we
we'll stand
go.
by for confirmation.
Oh, here we go. Look at that. That's a very interesting look there. Oh, look at that. How's about that? How's about that? Here we go.
And as we await that confirmation, great views from Dragon, now over
Oh
18 minutes
yeah.
into today's flight.
How's about that?
A
Wow.
successful liftoff, stage one. The sixth
Okay,
flight of the
here we
stage
go.
one booster made its way safely back to landing zone 40. Stage two carried Dragon the rest of the way as, again, we continue to stand by for confirmation of.
Whoa, that's actually
Continue to stand
one of
by.
the good view as well. Okay, okay, nice, nice.
And we just received confirmation that they were doing the Draco checkouts after nose cone deploy.
Okay, so looks like NOSCON deployment looks like already somehow confirmed by at this point, and now the Draco thruster um
And here inside of Mission
now
Control, we just got a
currently
great
being
call
checked
from our
out,
visiting
and
vehicles officer that the nose cone
just in
has
case
been deployed.
any
The Draco
problem arises,
thruster checkouts have
but
been
should be
completed,
good.
and Dragon is
Okay.
now on its way to
Okay,
the
already
International
complete as
Space
well.
Station. So now
Oh,
that it's
wow,
deployed and
wow,
ready for
wow.
its phasing burns to the orbiting
Okay.
laboratory with the
So
successful
that's
orbital
good.
insertion,
That's
I'm now
good.
joined
That's what we want to
by Bill
hear.
Spetch, the International Space Station Operations and
Oh, and
Integrations
eventually
Manager.
phasing
Bill,
burns,
thank you so much for joining
so he
us
can
today.
properly join back to
Yeah, it's
the
great to be here
he
again.
can join to the International Space
Bill,
Station.
this
So
commercial
yeah.
resupply services mission that just launched, for you, what stands out about
Okay.
this mission and what it brings to the space station? We talked about
That's
the
nice.
cargo and
That's
some of
what
the
we want
science
to
that's on
hear
board,
so
but
far.
it packs a lot in that spacecraft to bring to the orbiting laboratory.
Yeah, it really does. CRS-34 is another great example of how the space station keeps driving science and technology forward. This mission is delivering new research, hardware, supplies, all the things that keep our crew healthy and the laboratory
Okay,
running.
so this is what
Every
we
one of these
hear.
cargo
This
flights
is
helps us test
the
systems, study human health,
interview.
and mature
Okay,
technologies that we'll need as we go deeper into space. It's
interviewed
a reminder
with
that the ISS
the
is still one of
Bill
the most productive
Spetch, the
platforms
operations
we have for
integration
discovery.
manager of the International
And I've
Space
alluded
Station
to it a couple
program.
of times, but it's always a busy
So
stretch
it
of time for the
is.
International Space Station program. How would you describe the pace of operations that's been going on right now for the laboratory?
Yeah, the pace on ISS is always incredibly dynamic. We're supporting continuous crew operations, science experiments that are going on all the time, visiting vehicles coming and going, and various upgrades, all while preparing for the next phase of human spaceflight. The team is balancing day-to-day station operations with long-term planning, and it really shows the strength of our international partnership. Even as we celebrate milestones like CRS-34, the work really never stops on orbit.
And certainly does not. I know we had a chance to catch up with you during the pre-launch teleconference and more to come. And for those following along, be sure to visit nasa.gov for that information. Well, Bill, Artemis 2, not too far back in terms of mission success and a major milestone for not only all programs here at NASA, but just for the agency overall. How is the International Space Station shaping Artemis and future missions beyond low Earth
Oh,
orbit?
this is about between
Yeah,
the
the International Space
ISS program
Station
and then
is really the
eventually with the
foundation
Artemis
for
program. Okay,
everything that we
let's
do
listen.
from Artemis and everything going forward. Everything we learned about long duration missions, life support, crew health, autonomous operations, international teamwork, all of it comes directly from more than 25 years of continuous human presence on the station. Artemis 2 demonstrated deep space systems, but the confidence to send crews that far comes from the experience we've built in low Earth orbit. The station is where we test, refine, and prove the capabilities that will take us back to the moon. In fact, there were a number of hardware items that flew on Artemis that were tested on the ISS.
And again, the International Space Station, that foundational test bed to continue humanity's exploration further and further out into our solar system. Bill Spetch, it's great to see you. Thank you so much for joining us here today.
Okay,
Absolutely, always a pleasure.
that's very
That was
interesting
Bill
answer
Spetch,
we
the
hear.
International Space Station
So
Operations
basically, all of
Integrations
what we
Manager.
learned
Thank
about
you
the
again so much
Artemis,
for your time and
not
joining
only
the
from the
broadcast.
Apollo missions,
Let's
but
check
also
back in with
for
the team over in
from the
SpaceX. Ronnie?
cumulative experience gained
Thanks,
from
Joseph.
the
As you mentioned, Dragon has now
International
begun its
Space
journey
Station
toward the
program.
International
So
Space
yeah,
Station, executing a
there's
series of
link between
phasing
these two
burns to
missions,
gradually
between the
close the
Apollo
distance,
and also
with
the
docking again
ISS,
targeting
and eventually
Sunday, May
this is
17th at
these
7 a.m. Eastern,
cumulative
6 a.m.
missions
Central.
becoming
We'd
the
like to thank
Artemis
NASA for
mission
entrusting us with
eventually.
today's
So
mission.
that's
SpaceX is honored to be
practically
part
it.
of NASA's Commercial Resupply Services Initiative.
Okay.
Congratulations again to the teams on another successful
Yeah,
launch.
so I
To
also
stay up to date with all of our
will stream
upcoming missions here
the
at SpaceX,
docking
please be
and
sure to check out
arrival or rendezvous of
spacex.com/launches for
the
schedules and follow SpaceX on X.
SpaceX
That'll do it for me here
CRS-34.
in
We will
Hawthorne
see
today.
that soon.
Thank you so much for tuning in. Back to you, Joseph.
So nice.
Thank you so much, Ronnie. As always, it's been a pleasure to team up with you and share this launch again with you and the teams over at SpaceX. And we hope you will join us on NASA Plus, Amazon Prime, and more for our coverage of the final approach and docking of the
Okay,
Dragon
so
spacecraft. Again, beginning at 5:30
and this
a.m.
is basically
Eastern on Sunday, May 17th, not too
NASA
long from now,
just
for
saying
docking
it.
expected near
And
7 a.m. Eastern
for
Time.
all of you
Visit
here that's
nasa.gov
coming
for the
in,
latest updates on our
stay
coverage
tuned
and
on my
expected
channel
docking
because
times as
I'm
we
going
follow
to
the
stream it as well.
operations throughout the next
Okay,
couple of
we
days.
are going to
With Dragon
stream
safely on its way to
around
the
less
International
than
Space
38
Station, that'll
minutes.
wrap up tonight's
Sorry,
coverage of NASA and
less than
SpaceX's 34th
36.
Commercial Resupply
Yeah,
Services
less
launch.
than
Thank you for
36
joining us, and we
hours
hope to
from
see you
now.
again
So
on Sunday morning.
see
Until next
you
time,
soon.
this is Mission Control Houston.
All right. So that's it. We are getting ready. Here we go. Yeah, the closing remark. Okay, so basically that's it. Yeah, so thank you so much everybody for watching. As you have already seen, that is the launch of the SpaceX's Falcon 9 Block 5 rocket, carrying the carrying the uh, NASA SpaceX CRS-34 cargo resupply spacecraft mission, supply spacecraft into right now on the way to its journey to the International Space Station, which is located 400 kilometers away from Earth. Okay, we are going to see that soon. That's going to happen if we follow from this here. Let me show you. If I follow from this kind of website, it should be around 7 p.m. Yeah, the docking would be 7 p.m. here, local time, 7 p.m. on Sunday, 17 May 2026. So, yeah, because we are in Sarawak, in Borneo, we are 8 hours ahead of the universal time coordinate. So, this will be it. And yeah, just before the live stream of this one of this Falcon 9 block, before the stream as well, around 2 hours plus before this, okay, is the Psyche Mars gravity assist. Okay, it's already done, where it utilized Mars gravity to alter its path and speed on the way to the Trojan how do I say? Yeah, which will go on the way to the asteroid Psyche, okay, which is the metal rich of it. Okay, because I don't want to be confused with another mission as well, something to do with the Lucy Trojan asteroid, if I remember. Yeah, I don't want to be confused, so that's why I have to check again. But otherwise, it is what it is. Okay, we are going to see that soon. Tomorrow, it's going to be the Cargo Dragon CRS-34, the C209 will be docking and rendezvous or arrive to the International Space Station, which will be docking into the Harmony forward Nadir module, and then eventually tomorrow will be the launch of the Long March 8 from the Wenchang Space Launch site located in Hainan Island, China. We are going to see that soon as well. That one would be 3 hours and 40 minutes after the Cargo Dragon docking to the International Space Station. So we are going to see that soon. So yeah, thank you so much everybody for watching, and thank you for sticking by to the stream. I'm Dennis Suguwa, your host today for the SpaceX's Falcon 9 Block 5 rocket successfully launched NASA SpaceX CRS-34 cargo resupply spacecraft right now on the way journey to the International Space Station. So yeah, and also thank you for your patience, as well as my current health situation is not really that good as well. If you even hear multiples of time I'm just literally coughing, that's because of it. And also if you even hear my my kind of voice as well, this is not typical on how do I even talk so far. Yeah, it took me more times to get this by in comparison to usual day, but it is what it is. I mean, as long I'm not terribly sick, I'm still able to stream for now. So yeah, so please take care of yourself, don't be sick like me, and that's it. Thank you so much everybody for watching. I will see you soon tomorrow, around 36 hours plus from now. So yeah, thank you so much everybody for watching, and take care and stay safe. Bye bye, and see you soon until we meet next time. I mean, next time will be tomorrow. What am we even talking about? But but it is what it is. Sometimes I unintentionally make that kind of weird humor comedy, but whatever. It's good, all is fine. And yeah, stay safe everybody. We will back soon tomorrow. So bye bye. Take care, stay safe, and stay healthy. Don't be sick like me, okay? So please take care. Bye bye.